Yes. Hello. Can I point? Do you have a light pen? Hello? Hello? Okay.
Nevím, co to, jestli nemá mobil. Dám mu jedničku, uvaděči.
This has an easy button on it.
Everything turn on. Control from the mic.
No, it's okay? Okay, thank you. Yeah, Brooke, you start? You start?
Takže hážu mu. Můžu hodit stream? Můžu?
Still got a little bit more time.
Okay.
Well, actually,
We have 2 minutes.
So I might start early.
All right, thank you very much.
Okay. I'm just going to introduce the speakers now. We've got a few more minutes before we actually do kick off, but I'm Brooks Gover from Tirreno. I'm the session chair for today, and hopefully I'll be helping you ask some questions. In between our speakers, to begin with, we have Aladdin from the IPv6 forum in Jordan. Unless you've been hiding under a rock for the better part of this year, you would have heard that the IPv6 address space from IANA had been exhausted on the 3rd of February, and then most recently, when did it run out?
Here.
It ran out in yes.
February.
Yeah, and it also ran out in
February.
Asia, at least, or they started their last 8 procedure. And, well, in under a month we have the World IPv6 Day, and IPv6 is going to be a very hot topic for 2011 and beyond. And
Sure.
Aladdin will tell you what's happening from his point of view and also from the IPv6 forum in Jordan. Thank you.
Okay, thank you, Brooke. Good afternoon, everybody. Ladies and gentlemen, welcome. Thank you. It's my great pleasure to be here. Thanks for Tirreno and the organizer to bring me here. My name is Aladdin. I run a lot of IPv6 works in our Arab region and also on a global level. My talk to you today will be about IPv6. I call it really it's time. The time has come for IPv6. First of all, I have 60 slides around. I want to cover them in 30 minutes. So I will try to manage my time within 30 minutes to cover all the 60 slides. Some of the slides are straightforward and they speak for themselves, charts and so I will skip them quickly. I have tried my best to make the flow of information looks nice and in harmony. That's why I have put the flow of information in this kind of pyramid. Here I will speak first about the IP milestone introduction, and we can skip forward to how to roadmap, and then what is the current barrier and challenges for IPv6, and fourth, which is the most important for this conference, is why EU need to speak IPv6, and the last will be the wrap-up and the way forward. And here is the bingo. I hope that we will reach this stage. So, the IPv6. IPv6 roadmap really is not easy. All of you maybe are aware that the IPv4 and IPv6 are not compatible protocols at all. So they are not backwards. You need a lot of reserve of knowledge, experience, and action now. And what is true in IPv6, it is that the only viable way ahead. So it's really time to act. Why is that? We will see that because the IANA pool for IPv4 have been completely depleted in 4th of April this year. So what is left with the 5 RIRs all around the world are just a few blocks to distribute IPv4. So there is a big push for IPv6. Everybody is saying go ahead for IPv6 because IPv6, you know very well, that has a very, very, very large pool of addresses that will not be exhausted. So for the IPv4 addresses, sorry, it's finished, and sorry, we are closed. Now it's time to go for IPv6. I have did this chart. Maybe it's interesting for you to see. I simulate the current internet with the current fish, which have been flowing nicely in the water all the time past, but have been prone and subjected to many, many problems because of the initial IPv4 design, which was not designed for this kind of a huge scale internet. So this fish, the internet, have been susceptible to many problems: congestion and delay, mobility convergence, NAT layer. For IP shortages, NAT layer is the technique that is used by the ISPs to deal with the scarcity of IPv4 and too many security attacks. So this is in general the big families of the problems and the issues that is currently facing the IPv4 backbone internet. Now, why IPv6 is important? It's for business continuity. You cannot grow, whether you are a vendor or whether you are an ISP or a content provider, you will not grow with this current IPv4. And for IPv6, everyone get connected because of the huge number of mobile users, which are around 6 million right now. All of them need unique IP addresses, so everyone will be connected. New opportunities for the market. End-to-end IPsec. This is relatively specific to the security issues because the IPv4 have many flows and many flows in the design which have been intelligently used by the hackers to attack the internet, various kind of attacks, attack the protocols, application layer, network layer, etc. So the IPv6 provide this IPsec, which is a protocol embedded in the IPv6 protocol to solve the security issues for the internet. Also the peer-to-peer connections. The IPv6 will restore the original model that is designed for the internet, which is end-to-end communication. Every end connection should need a unique and a specific IP, which have gone with the IPv4. Now the IPv6 will restore this model. So what is needed really? IPv6 end-to-end communication, secure communication. This is what is needed really. As we said, the IPv4, we have multi-natting across the road. Every ISP use natting, and many ISPs knew using natting, behind natting, which became the religion, the sacred religion for them, and they object and they refuse the move to the going forward toward IPv6 because of the natting. They say always we have natting, we are happy with it. It will solve the problem. No, this is completely wrong. This is a short-term vision. The long-term vision should be an end-to-end communication which is provided by the IPv6 secure transmission. Every node, every host should have a unique IP addresses. So IPv6 will restore the end-to-end communication model. Now, the IPv6 standard profile, this is basics of the IPv6, basic requirements. This is too much technical information, but I thought it will be useful to put them. For the addressing, routing, equality of service, it will provide equality of service. The transition mechanism, we'll see a couple of charts in a while, shortly, about how we transit or how we migrate from IPv4 to IPv6, called dual stacks and tunnels, etc. Also, for the IP security, we need this to enable these embedded protocols within the IPv6 protocol suite to have a real security. Otherwise, if we don't enable this, IPv4, IPv6 and IPv4 are similar in security. If you don't use this in IPv6, then you will do nothing security wise. Also, it should be some kind of network management for the simple network management protocol and all this, multicasting, mobility for the using of mobile and ad hoc networks, quality of service we have mentioned, and all this stuff. This is a pure technical. The network engineers should be aware of all these aspects, which are explained very clearly in many requests for comments by the IETF. Now, the IPv6 defenses, what's new? Now, everybody is asking, what's new in IPv6 defenses? In fact, there are 4 major blocks. The IPsec, which is will provide authentication and encryption of all the traffic. The CGA, the cryptographic generator, the unique local addresses, and the send, which is based on the CGA, which is for secure neighbor discovery. Also, there should be a firewall model change. The current firewall model change will not work and will not be more secure if you cannot change it. All the explanation and deep technical explanation of these are explained clearly in this request of comments, which is beyond the scope of this talk. I just want to highlight why we need to move to IPv6. So, as we said, for the IPv6, we need security. Security is very important. So, we need security using the IPsec. IPsec is considered of 3 major blocks: the authentication header, the encapsulating security payloads, and the internet key exchange. Here there is a brief of what each of those is doing. Briefly, it's provide a complete secure channel for transmission of the information. Now, how to roadmap? This is the in the first part of my presentation, I spoke about the basic milestones of IPv6 or the building blocks. Now, how do we move to IPv6 really? First of all, the IPv6 transition model is not an easy. You have to work heavily on this. You have to do inventory assessment. That means you have to do an inventory of all your hardware and software currently and check their compatibility and readiness for IPv6. This can come in an Excel sheet or whatever kind of inventory that you do. You have to list all your equipments and the software and the application and check their readiness, whether to be replaced, upgraded, and so on. You need to do also an IP strategy and architecture. This means you have to do a timeline for the transition. Nobody will do an IPv6 transition overnight or in 1 month or in 6 months or in 1 year. It will take 3 to 5 years depending on your budget, on your transition. But this is meant by the IPv6 strategy and architecture. You have to do a phased timeline and decide which part of the network you will start with the transition. Usually, so you start from the edge and you go down to the core. This is the IPv6 design and engineering, which is designed the networks by the network engineer of the enterprise, and also testing and piloting. This is very important. You have to test every part of your networks. Usually the enterprises, the ISPs build test labs for checking the routing, the addressing plan, which is the most sophisticated issues of the IPv6 is the addressing plan, how to assign the blocks, the /32 or whatever, how to distribute it to your clients, to your LANs, and so on, and the transition planning and the governance. So this model shows that the work of IPv6 takes a long time, and it needs to be really very good designed. Include the supporting infrastructure, the internet connection, the computer center network, the external services, the domain name systems, the DNS. As you maybe all of you know, that the DNS is very crucial element in the internet, which transfer the IP into the names that we know. So you have to deal with the DNS for the IPv6, web hosting, internet, email systems, etc. Also for the internal services. So let's suppose we start from here. We have to review the existing network infrastructure and application. We design for the new network infrastructure and so on, and implementation approach and roadmap and the best practices. Usually the global community now, because of the IPv6 is new and everybody is trying his or her best, usually there is share of knowledge about the best practices. So this is another snapshot of what I have talked about: the design, low-level design, the preparation phase, the pilot phase, the deployment phase, and operation and optimization phase on the long run, and all what you have to do in these phases. Now, government IPv6 policy. Personally, I believe that the best IPv6 deployment practices shown so far is with the government enforcement. So the policy should deal with the cost, with the timing, with the options beyond the IPv6. For example, for the cost, what are the variables, what are the priority, or how we distribute and schedule these costs. For the timing, we have to deal really with the problem of IPv4 exhaustion. What we gonna do? Are we going to stay? How we deal with the NATing and so on? We have to look carefully for the policies in the other countries. Like I said, we have to share the knowledge. We have to activate time starting from day 0 to day 1000 or whatever it is. Also, you have to think about the other options beyond the IPv6. Now, for the priority, this is maybe a straightforward chart about the cost and the value. You see there is low, medium, high, low, medium, high. For example, for the cost estimates, if your nodes are less than 10 million, so what is the value? Here you have for the external services, sorry, let's start from here. For the external services, the DNS, the email, and so on. For the nodes which is less than 10K, 10,000, the cost could, the value could be medium, and the cost could be low. But for the connectivity expansion, if you have nodes less than 10 million, maybe the cost is medium, and so on. For the internal use and all IPv6, internal services and database, desktop, hardware and software, usually they are high costs. Now, I think all of you, or most of you who are working with the IPv6 know that there are 3 major, in fact there are 16 plus transition mechanism, but the major three are dual stack, protocol translation, and tunneling. Tunneling, there are various kinds, like here called 624, 6RD, rapid deployment, is a tab by Microsoft, Redo, Tunnel Broker, and so on. So, and dual stack here, it is usually dual stack is that the both ends will speak both languages. So if you have a host or router, you will speak v4 and v6. For the tunneling, usually the tunneling is that you build a tunnel, a v6 tunnel inside a v4 network and so on. Protocol translation is difficult because you have to translate the complete protocol, the v4 protocol, into v6 protocol. What is important here regarding the tunneling, there are two kinds, manual and automatic. There are several vendors like Hurricane Electric and etc. who can provide you with a ready tunneling, v6 tunneling. Well, there is a lot of suspicions about the security because you will be under the mercy of a third-party vendor. It's better to have your manual tunneling, which is not easy. In a nutshell, you have to expect all these possible scenarios. This is the same chart, but in a different way. I will leave it to you. So for the IPv6 security plan, you need to know about the equipment configuration, the perimeter defenses, the firewall, the acceptance list, and the IDPS, and so on, content filtering, mail filtering, patch management, how to deal with your vulnerability of the equipment, how for the AAA and so on, for the DNS, and also how to deal and figure the parameters with IPsec, which is very important. Now, what is the current barrier and challenges? There are challenges ahead. These are the major challenges and barriers for the IPv6 now: broken location aware services, broken applications, poor performance, and worst case scenarios, the multiple NAT and carrier grade network in a row. These are more or less deep technical experience that the network engineers will be faced off. This is a chart which may be shown better kind of the barriers. Here we have IPv4, which is flowing, and IPv6 is broken. Why? Because of the poor IPv6 connectivity, unmanaged transition mechanism, unmanaged addressing plans, no IP connectivity, but quad A. A quad A is which is used for the DNS, for the v6, and no global connectivity. There are many risks here. Also for the DNS, many broken v6 user cannot reach the website because of the quad A well-known problem. So many many enterprises think that the best solution for this is to deal with two DNS, DNS for v4 and DNS for d6. Also, the technology adoption and absorption by the personnel is not easy. For example, the IPv6 was started in 1992 as a standard and approved by, I think, in 1999 by the IETF, but it takes many years for the adoption of technology. Usually people will resist in the beginning for adopting the technology. So why EU needs to speak about IPv6? I think all people in the EU knows this chart very well, which is a very ambitious plan for the R&D arena in the EU regarding the projects, IPv6 test beds, and so on. So the most important here about the EU is that the EU have, sorry, the EU have issued a policy document in 2008, is written in this link, you can find it. The plan was a milestone plan that 25% of the EU users should be in IPv6 enabled by 210, which is the last year. That was the plan in 2008. So cooperate with the following milestones of major blocks and major contents, cooperate with content service providers, encourage ISPs for IPv6 connectivity, encourage member states to use IPv6 awareness campaigns, and including of the IPv6 in the curricula and so on, and security. This is the major blocks of this plan. But for this, I will use this, it's better. For this, there are many events and actions and research and development done by the EU. So here is what, and here are the highlights. Many events, seminar, workshops, and groups about the IPv6 work, promotion work. I will leave it for you to read and explore the websites for more information. This is the second one. But what was the result? The result, just 2% over the originally planned 25%. I didn't bring this number from my own. It was the last statement given in V6 World Congress in Paris in February this year. So why is that? Only 2% out of 25%. Is not okay. Need help. What kind of help? We need to develop, EU need to develop IPv6 skills widely, sustain EU research efforts, accelerate work on standard specifications, and promote the advantages of IPv6 to all economic actors, more multi-stakeholders collaborations, and more inter-EU states and international collaborations. This is the conclusion of what EU should do to give a password. Thank you. So, this is not working. Okay. So, why is needed for the EU? IPv6 cluster should be embedded and included in every arena of the R&D and NREN and so on. So, these are the milestones of the ICT program FP7 and the newly coming in June FP8 for the EU, the digital agenda for EU, which have been released in 2010 up to 2020 for 10 years, the social networks and the future media, and the NGN here, and trustworthy networks and so on. All these elements are part of the EU ICT programs. IPv sector is included in every arena. Now, I will leave this because I don't have that much time. This is the future internet application, the vision of the EU, current, the scalability, the mobility, the security, trustworthiness, and networks and services, and the technologies. All of this are shown here. All of this need to be IPv6. Also, the digital agenda, which have been released last year, have addressed 101 ICT actions. There are gaps in these, which is explained very in details in this link. I'm taking this information from this link. There are 21 gap actions in the digital single market. There are 7 gap actions in the interoperation and the standards. There are 8 gap actions in the very fast internet, and so on. I will leave it to you. You can go to this link and see these gaps in details. And IPv6 enabled and ready should be, as I said, enabled in every stone. It will be a benefit for the e-learn vision, for 3D internet, smart grids, cloud computing, ICT and climate change, RFID, and so on. So the future internet, there are visionary challenges as addressed by the EU, more and high volume traffic, a public good, and open and fair access. IPv6 should be there in every arena. And the technical challenges regarding the efficient radio access, the real-time form and new forms of ad hoc communication, the integration of the sub-networks in the edge, the barriers to the broadband access, E2E networks and services, high-quality media, green IT, and so on. So as for the NRN for the EU, I believe this is the model of the EU Internet and GNT, run several NRN for the EU countries. So the most important for the NRN should be organizationally connected. There are IPv6 migration costs and no apparent functional improvement for the end user. What this means is that there are many NRN individual in the Europe. They have IPv6 in their backbone, but they are not connected. I think this will give more value to the end users. Also for the CERT teams, collaboration for the computer emergency response teams, and the services can be provided more jointly, and more collaboration between the NRANs and the ISPs, commercial ISPs, and make use of the IPv6 shared traffic. Now the road up and the way forward, we need to accelerate the IPv6 adoption. These are the kind of multi-stakeholders that need to be engaged. These are the pull factors and the push factor. For the push factors, we have to raise the awareness and ensure the equity of the IPv4 and IPv6. We have to create the initial IPv6 demand, the users, the content providers, and so on. These are all kind of actions that needed to be done for the policy, position statements, RIR policy statements, IPv4 exhaustion, how to deal with. This is regarding the policy-wise, reduce risks of the ISPs, and for the operation, all kind of actions needed to be done, and the constituent services. Feasibility is the technology, economy, operation, and the legal. All these need to be taken care of. So please keep in mind the IPv6 defenses, the SEND, the CJ, the ULA, and the IPsec, which I have explained. I will leave it for you. Also, I have written for you here a kind of table, which is useful table for those who want to go deeply for the IPv6. These are all the technical information. Should go to these requests for comments. I will leave it to you. And the finish, I want to highlight some kind of my Arabic region status in the IPv6 and RN. Here, some key milestones for the IP4. I have listed here some countries with what have been done regarding the IPv6. I will leave it for you. I think this is supplementary information. For the NRN, there is Ankabut in UAE, but here are many challenges for the IPv6 and NRN, which is very, very much. I will leave it for you. Maybe I don't have the time to talk about it, but it will be good for you to know the status of my region. And this is my personal conclusion of how the Arabic region go forward for the IPv6. Also for the NRN, the current status, I think there is a guy, a friend of mine, colleague Dr. Yusuf Truman, who will speak tomorrow exclusively about this. And the finish is a very big journey waiting for you for the IPv6. And thank you very much. Stay tuned. Thank you very much.
We don't have a lot of time, but are there any questions for Aladdin? If not, he'll be... Yes, there is.
Oops. I'm sorry. Yes, please.
You have shown a lot of techniques for the transition from IPv to IPv6. What technique would you recommend? You've shown Teredo, IP6 to 4, and others.
Usually there is no answer. In IPv6 there is a wisdom. there is no answer but possible solutions: dual stack and tunneling. Usually that's what have the major ISPs have started with in a mixed environment. Dual stack at the end, both your ends, your users, your host, routers speak both v4 and v6, and for the backbone and infrastructure, tunneling.
Excuse me, may I pick in here? The problem with dual stack is that you need two addresses. One is IPv4, and the problem in the moment is that you don't have IPv4 addresses. So that is actually the challenge, to have hosts running that are not dual stack but IPv6 only.
Okay, to be quick, the answer for this is running for the current systems. IPv4 and IPv6 will coexist for a year. You will not go and take IPv4 and throw them away. So for the current system which have IPv4, you enable IPv6 and they speak both languages. They will coexist for a year. Many estimations say 10 to 20 years. But this does not mean that we do not start. We need to start right now for the economic growth and the global ICT for the EU or for the countries. Okay?
Thank you very much.
Thank you.
You can always catch up with Aladdin during the break.
I'll be more than happy. My contact information is here, and I'm more than happy to answer anything during email or whatever later after the event. Thank you very much.
And, yeah, applause, of course.
Thank you.
Okay, next up we have Miriam from the RIPE NCC, which hopefully is an organisation very familiar to one and all. Oh, we have to do a mic changeover thingy. Okay. You don't have one. Okay. So, you stand there. You get mic'd up. Alan or other people can ask questions. In fact, the RIPE NCC organised the translation of the Surfnet numbering plan. So, and I think the RIPE Labs site has statistics on how popular that has been.
Okay.
And I've retweeted it, so if you're following the TNC 2010 hashtag,
silly?
you can look it up again. It's
looks
been
silly,
tweeted
I
by many
know.
people before.
Sorry, my mic's already on and I'm doing jokes.
A question? Come on. You want to ask a question?
Okay, it's okay. Is it on already?
Hello, Alan Buxey here from Loughborough University in the UK. I manage a fully IPv6 enabled campus network. About 60% of the subnets on the network are fully IPv6 enabled, and it's been an interesting experience. I was going to put it to the audience here. How many of you actually have IPv6 networks, and is it a case that we're talking rather than actually just doing the work and doing it?
Not bad.
For those that can't see the hands on the stream, that was, well, 75% maybe. You think? It was a high percentage. Yeah, we in the trainer secretariat, our sysadmin is excited about IPv6. In fact, so much so he's not excited about 32-bit addressing and has turned it off on nearly every service. That so there's only one printer that you can print to with IPv4 only. That's for guests. Next up, Miriam from the RIPE NCC.
Thanks for the introduction. Well, it looks like I don't have to do a lot of promotion here because you're already doing all the IPv6, so that's great. I still want to talk to you a little bit about, let's see how this works. This one. Maybe not. Maybe this one. Very briefly, just an introduction about what the RIPE NCC does, and then I just want to walk you through some numbers, some statistics from us as the regional internet registry, what we see at the moment, what's happening with IPv6, and show you some recent projects and measurements and promotion activities and training activities that we're doing at the RIPE NCC. Just a very brief overview. There are 5 regional internet registries in the world that hand out IP addresses to the communities in those regions, both v4 and v6 NIS numbers, and the RIPE NCC is one of them. Sorry. Yes, excellent. Thank you. Great, thanks. Yeah, the RIPE NCC is one of them. We are an independent, not-for-profit membership association, and in fact, we actually started under the umbrella of Terrainer, or what it was called at the time, RARE, and then became independent and started our own not-for-profit association in I don't know when that was, 5, I think. And so we now have over 7,000 members. We call them local internet registries. And a lot of the NRENs that are here are also members of the RIPE NCC and are probably familiar with all this. Here's our service region again. Right, just dive into some statistics, and this actually shows the RIPE NCC's IPv4 pool and how we're running out. A lot of people ask us and contact us about when are we, reaching the end. As people mentioned before, the IANA ran out of IPv4 addresses, and so the RIR still have some left locally. So we're still working on. We still have IPv4 addresses. IPNIC ran out faster, but we still have some. The yellow line there at the bottom is the last /8, so that's in millions. So that would be 16 millions, and so we're kind of slowly going down there with our IPv4 pool at the RIPE NCC. That's just the RIPE NCC. On the other hand, we also see an uptake of IPv6. Well, as you see, the numbers are a bit different there. So this only illustrates really that we already started quite early handing out IPv6 addresses, and you could probably say at the first few years they were mostly like early testers and research institutions, and then there were was a phase where people kind of started to ask for IPv6 allocations, and then in 2008, 2009, it kind of picked up, and then recently, obviously, it picked up even more. As you can see, probably not so well on this one. Early this year, we saw some big spikes in IPv6 requests that we received from our members. Now, let me go into some of the projects and activities that we are doing to promote v6 and help to explain what people can do. And transition mechanisms came up, and also have some information on that later. And on the IPv6 Act Now website, IPv6actnow.org, there's a lot of information for various communities. We initially set it up for government representatives or technical staff in governments, and also policymakers, so they can learn some more about what IPv6 is and all the different issues, and make sure they make the right decisions. But then we expanded it, and so there are different sections now for ISPs, small businesses, government representatives, enterprises, and there are some statistics on there, interviews with people about how they set up their networks, how they promote v6, what the issues are they were facing. So it's kind of a bit of a one-stop shop for IPv6 information. It's fairly high level. There's not so much technical details on there, but we might add that later as we go along. So I think I mentioned that already. It has statistics in some new sections as well. Right, then there's another website. It's called labs.ripe.net, the RIPE Labs website. We started that last year, and that's it's a bit of a blog environment. It's a platform for the RIPE NCC to put out new ideas we have, prototypes we're working on, measurements, statistics. But it's also a platform or website for others like you, the community, that you can also use it to promote or publish things that you're working on. So there are also external contributions on the RIPE Labs website. In this talk here, I only wanted to focus on some of the IPv6 related activities or measurements that we've been putting up there from the RIPE NCC. But if you go to labs.ripe.net, you'll see a lot of information. There is a tag cloud and some search functionality. If you search for IPv6 or measurements or tools, you get a lot of information. It's mostly focused on operational tools and information. And so they're just some snapshots of things that are on that RIPE Labs website at the moment, and I wanted to just highlight some of them. Maybe some of them grab your attention, and you can dive more into it when you go home. IPv6 ripeness, some of you might have heard about this. We started that a while ago. It's basically a rating system. We thought, well, how can we promote v6 among our community, and how can we maybe even set up some competition a little bit between LIRs, between the countries. And so we set up this rating system where we check in our internal archives and also in the RIPE database and the routing system how well ISPs deploy IPv6, or how our membership deploys IPv6. So we thought, well, the first step would be we have an IPv6 allocation from the RIR, and so then you get like 1 star, 1 checkbox, and then you can earn additional stars, for instance, when the v6 prefix is routed, and we can see it in the routing system, when there's an object in the RIPE database, and when reverse DNS is set up. And this turned out to be quite a successful way to promote v6, and to also actually have governments look at it and say, "Ooh, our country is doing not so well, compared to our neighboring countries, and what can we do to promote v6 in our country and to increase the numbers there?" And so we keep updating this, and I just wanted to show you some stats. That's the RIPE NCC service region as a whole. As you can see, still 62% of all our members don't have any IPv6 address space, or at least not allocations from the RIPE NCC. So again, this is only RIPE NCC members, so it's not end users or customers of ISPs. 13% have like all 4. Well, you can see like the left part of the pie are all the LIRs that have some sort of IPv6 deployment, and only 13% have all those 4 criteria that I just mentioned. I thought it might be interesting to look at the Czech Republic. They're doing a bit better than average than on global level or on the regional level. 55% have an IPv6 allocation at least, and 26% have all have it routed and reverse DNS set up and a route object in the database. So just to show you that, it's just another way of looking at it and comparing. And again, the Czech Republic is doing fairly well compared to other countries. Right, another project we started was about how else can we measure IPv6 is, well, look at the networks or at the IS numbers that announce IPv6 prefixes. So we looked at this over time and how it changed for various countries, and we actually initially developed this for the OECD, who were interested to get some indication of how it's going and how various countries are deploying IPv6. So this is all countries, the entire RIPE NCC service region, so Europe and abroad. And then I just added some more countries just to see how people are doing. This is Poland, Ukraine. Germany is doing pretty well recently, and then there's the Czech Republic. And they're they look a bit different, but it also depends on the size of the country and the number of IS numbers in that country, obviously. So if more IS numbers are added, then the graph changes. So it doesn't necessarily mean that they're actually going down, but you can see the details on that website there, and you can also see different country-specific pie charts and more information there. Right. Another topic, another activity. The IPv6 transition mechanisms. Yeah, we also heard a lot of questions from our membership and also other conferences about, well, now we have IPv6 addresses, now we got an allocation, now what? What can we do with it? There are all these transition mechanisms out there. What's the best for us to use? And so we started, writing some documentation, and we thought, well, exactly the question that came up earlier. So what's the best transition mechanisms in my situation to use? What if I don't have v4 addresses anymore? Or what if I still have v4 addresses? And what can I do to allow my customers to, reach the v6 network? And so this is still work in progress. We're working on this decision, making tree. It sounds bigger than it is. It's pretty much just like a flow chart. Like, yes, are you a content provider? Are you an access provider? Do you have v4? Yes, no. Do you have control of your equipment? Yes, no. And then in the end, ideally, only a couple of transition mechanisms will flow out, and then you don't have to know about all 16 of them. So that's the work in progress, and we'll hopefully have that ready soon. That was also discussed last week at the RIPE meeting, and the IPv6 working group of RIPE might actually pick that up as an activity. At the bottom there are some links about some measurements a colleague of mine, Emil Arben, has done about 624 and the brokenness of 624, and he measured that and put that out there. Another thing we've done like a year ago together with Marco Hogewoning, who was at Access for All at the time, and he contacted a lot of CPE vendors, like vendors who sell customer premise equipment, and was trying to find out if they are IPv6 capable, and so he sent around a survey and gathered some information from some vendors. Not all responded, and then once he also tested. He had his own test bed and he tested it, and we made this whole matrix. It's all on RIPE Labs. You can find it there. Made this whole matrix of all the features and what does the vendor claim, and is it user confirmed, and it became quite a big and complex project and difficult to update. And also, when can we say it's user confirmed if one user tested it or 10? Or so we recently decided to do this a bit more properly and structured and set up a survey. You probably can't read this there at the bottom. It's the link to the survey. If you go to RIPE Labs, you can find it there on the front page. It's targeted to vendors and operators and users, and it's a bit technical and complex to go through, but it's I think it will be very useful for others to see the results. We have more than 100 responses now, but it's still open. So please, if you're using equipment at home, or if you're a vendor, or if you have any experience or tested it, please help the community to make the right choice when they go and buy one. That's pretty much what it boils down to. Well, we also do IPv6 training courses. There'll actually be one here in Prague at the end of the week. One of my colleagues is here, and she will give an IPv6 training for members, for NCC members, so local internet registries. We also recently started doing things called IPv6 roadshows. They're mostly targeted to technical staff of governments or other institutions, and we started doing them in the Middle East first. So the previous speaker is probably aware of this, and we're doing this together with local hosts and local networking organizations, and that's been quite successful. We might do it in other regions as well. And obviously we're presenting at conferences and other meetings and promoting V6 where we can. And finally, I think I'm early here, we mentioned V6 in the abstract of that the World V6 Day in the abstract of that session here, and I think you all kind of heard there's something going on the 8th of June, and I think this will come up during the week some more often. And I just wanted to mention here what the RIPE NCC is doing to help that. We're not, so the main purpose of the IPv6 World IPv6 Day is some content providers came together and said, well, let's switch on, let's provide content over V6 and see if things break for our customers. And obviously not one of them wouldn't want to do it alone, so they coordinated this, and it became quite a big initiative now. And the RIPE NCC, we provide our content over IPv6 for years now, so that wasn't what we could do for that day. So we thought, what could we do? And so we decided to do a lot of measurements and monitoring before and also on the day itself, where we can see, how things break and prepare people also for the day. And there will be like a chart on the website where people can test their connectivity and see if they have problems on that day. They can all be found on the RIPE Labs website. And there will be 2 physical events. I just wanted to mention them here because there might be people from these countries. There's one in Amsterdam and one in Moscow, where we'll actually do a lot of V6 related activities on the day itself. And I think that was all. Are there any questions? I hope I wasn't too fast.
I'm sure you're not. No? Not working. More questions? Clearly there need to be.
I was too fast. I was too fast.
I use commodity at home, and I've got no choice other than my one cable provider. And apparently, what do consumers have no power, do they? Do I have to just wait? Wait and hope they'll make the right choice?
Choose a different provider.
Who the Dutch provider?
One in your country that provides one.
And in my other country as well. Yeah.
Yes.
Yeah, there's not many though. Yeah.
Hi, Scott Armitage from Loughborough University. I briefly mentioned to you before the talk today when I saw you. On the survey, the CPE survey, there's no mention of OpenWRT, which is probably one of the more popular methods of getting IPv6 in the home environment, because you can run it on so many different manufacturers' hardware and terminate tunnels on it. So I think it'd probably be useful if that was added to the CPE survey.
Yes, thanks. You mentioned that before. Yeah. I'll take note of that, and we are going to do that in the next version of the survey, I guess. Yeah, it's kind of hard to put it in now, but it's a good point. Yes, thanks.
My mother can't install OpenWRT though. What? I have to go back to Australia to do that. I do love her that much though, in case she's watching. Okay, no other questions about IPv6 for Miriam?
Well, I'm around here pretty much all week, and we also have a booth out there, and so you can ask me, or we have a few more colleagues here during the week, so you can ask us all questions you might have. Thank you.
I think this is... Yeah. So while our next speaker microphone's up, we actually had a presentation by Robert from the RIPE NCC about World IPv6 Day at a meeting earlier this morning, and so I looked, and we only have 39 national members in Tirrena, and 27 of them have an IPv6 capable website at this point in time. So 12 of them could prepare one for World IPv6 Day, but hopefully all their networks, I'm not sure the status of the networks, but hopefully they are actually running and offering IPv6. But Maurice will be talking about, well, a case study on IPv6 adoption.
Yeah, that's correct. Thank you. I'm Maurice van Akker. I'm from Surfnet. I work with Surfnet as a product manager for the network connectivity. Are you aware of what Surfnet is? The Dutch National Research Network, connecting about 180. No, no, not at all. You shouldn't know. 180 institutes, and we provide network services, of course, but we don't. As in comparison with other NRNs, we don't go deeply into the networks of the institutes. And in this talk, I want to speak about how we want to provide our institutes with the use of IPv6. So, are you doing all right in this room? See a couple of people staying on the back. There are a few chairs over here if you want to sit down. But if you like standing up, okay, you're all right. Well, this is a picture of my colleague. He's not all right. When he was young, he started with institutes to help them with IPv6, and he's very tired and old now, and it took him a lot of time. Since 1998, he started with he started with the IPv6 part, and he wanted really the institutes to adopt IPv6, and he made tunnels, he made the Surfnet network native IPv6, he made courses, workshops, seminars, but nothing happened, and maybe one or two institutes adopted IPv6 in their networks, but that was it. So the timing seems very bad, but the good news of course, when he became older and older, also time elapsed, and it seemed that since, well, 2 years, that people are getting more interested, at least in the Netherlands, but as we said, as we have seen with the previous presentations, also in other countries. And we started with the technical workshops, and we saw that, it was really hands-on workshop. There was only room for 12 persons, but people were coming to it. And in 2010, we started with an IPv6 workshop. We wanted to have it broad, so we announced it as a workshop where we would go from a business plan towards technology. And we were expecting about, well, maybe 12, maybe 20 persons. But it sold out, actually, and people were asking, can I join? I'm on the waiting list. Please let me continue with it. So we were kind of shocked by that, in a positive way, of course. But it made us think that maybe it's time to start doing things. And the things you see here in the continuity seminar and the support team on site, that's the things that I'm going to talk about. But what happened within those last 2 years? Is it, it's no more IPv4 addresses? Is that really the trigger that made people going to that? Well, who cares about the IPv4 address? Because especially in our at our institutes, the educational research parties, people have enough IPv4 addresses, and that's if you ask them, and I will ask you too, who has enough IPv4 addresses and therefore does not care about the IPv6 yet? Can you raise hands? Then you can see that still a few people believe in this myth. If I ask it to a broader audience, then mostly 50% say, yeah, we do. But they mostly forget that there's another way, another party who's willing to communicate with you. And if that party is IPv6 only, then you really have a problem. It takes two to tango. Especially at our institutes, they notice that Chinese students are very interested in coming to study to the Netherlands, and as we have seen in the previous presentation, it might be very well soon that in China, for example, there are only IPv6 only networks. So that will, I state here, that will make sure, they will be afraid that such a Chinese student cannot communicate with the web service anymore of the institute and will not come to study there. So that's one, you could say, scare of the institutes and a driver for IPv6. Another one is, of course, the mobile networks, which are growing very fast. Some mobile operators already thinking about going IPv6 only, and that's as you can, that's the same issue as with the growing markets. If you want to have those customers using your services or going to your website or whatever, you need to be enabled. Other thing is the Internet of Things, all the kind, you can say the small devices everywhere in the world measuring everything. We saw it in the keynote speak this afternoon. If you swallow something and it measures something, it probably is IPv6 which communicates through it. So if you as an institute want to do something with these new devices, you need to be IPv6 enabled as well. Another issue that our customers are having is the desktop clients, Windows 7, and it's already talking using IPv6 even when you're not enable it on your network, so that it's a real threat for their ongoing business. And if you look at IPv6 overall, it's a network rollout. There's not only an impact, a little impact, but it's a big impact for the numbering, the routing, security, redundancy, load balances, monitoring, troubleshooting, etc., etc. And well, continuity is actually the driver for IPv6. What we see now in our networks, and you can say maybe a fear of continuity. So this is what we. This is our message to the institutes. But of course, yeah, it's our message only, and yeah, institutes. Well, they say Surfnet, thank you. It's good that you say that, but let's see what happens. So we do not only giving messages, but we also try to do other things. I will go into detail now with the 2010 part, the broad IPv6 workshop. You see the timing seems a little better. Oh, sorry, this is I forgot one, the IPv6 technical workshop, what we did. I talked about that. The workshop, before we started the workshop, we thought about IPv6 and we tried to categorize the problem. And we defined 6 categories for that. One is business case, one is routing, security is one, numbering. We had a separate part, application and licenses, and the transition, or the adoption phase, you can say. And the steps we took is with the 80 people coming to our offices, we organized a creative session. And yeah, what's a creative session? We separated the people in those 6 areas. We put them in a different classroom, and we put an organizer or yeah, you can say a moderator with them. And we said, okay, now it's your turn. We were for 10 years we were talking to you. And, well, we were talking, but now it's really your turn. Can you think of with the group you are in now? Can you think of 3 items you want to arrange the next year? That's actually what we asked. And well, of course, people were looking at each other in those sessions for, well, what are we going to do? But well, within a few minutes, well, people were really started to talking and sharing the problems they had, and it made, yeah, they really made good progress. And in the end of the sessions, we had each attendee had 2 sessions it could attend to. Each session take over an hour, and they really appreciated those sessions. And what did they do there in that hour? They made questions like, how can I convince management about V6 deployment? That was the thing they shared, of course. Well, they come up with a top 3 calculations they want to make. They needed a template, they needed business plans. Another one was they want to log MAC IPv6 addresses in the case of stateless. And yeah, the things came out was that they needed to research the possibilities of external logging and capturing, parsing DAT packets, and that was the thing they were looking after for. Another questions, as mentioned before, was how can I organize my network numbering? Yeah, well, we had to gather the current practices and build the how-to. That was actually one of the outcomes of that creative session. So what were the results? We had that about a year ago, that session, and with the separate groups we created there, we continued. And of course, one group was lagging behind the other group were faster. But we managed to get a few results, and one of the results is well, in the section business case. We made a few interviews with customers, and the main question what came out was how can we determine the right moment to start with IPv6. Therefore, we created a business case considerations document, and it consists of opportunities, risk of continuity, timing, impact analysis, cost, and also CAPEX, OPEX Excel template for the really people who like financial figures. And this is a part how it really looks like. And I think it's okay. It's a good start, but it's not It should be more in it. And of course, when you start working with such a template, then it gets filled in, and then you really can have something, really do something with it. But that's work in progress, as we could say. The second part was numbering. As you said before, there was a plan written, a how-to plan about how could you number your IPv6 network, and it was really for us, for Surfnet internally, it was that's obvious. Your V6 network, your numbering plan, that's not that hard. But in the sessions we had with the institutes, it really came up that it was really a problem for them. And then we thought, yeah, okay, we are ISP, and ISP is I think different, of course, than local networks and the customer. So, and when we wrote it, it actually was unique on the internet. And then RIPE translated it into a very beautiful document and put it online. And the first week already 8,000 downloads and a lot of retweets, as you said. And we were really astonished by that. And such a numbering plan is also a good start for institutes to think about how they would deploy their IPv6 in their network. It makes you think of how should we subnet, how should we continue with routing, or how should we think about security in a better way, or think about the future. Hey, maybe we're going to move from buildings in a couple of years. How should we take care of that in our IPv6 number plan? Another document that was written was how to implement IPv6 on a local area network, and what can you, what kind of things will you drive into if you do that? What kind of problems? Here's the table you see over there. Is really an example what you can find in this document. It shows just for the operating systems. It shows what kind of versions has which problems. And in fact, all kind of things according configuration, DHCP on-campus infra will be addressed in that document. All available on www.surfnet.nl/IPv6, also in English. Another thing that's going on within Surfnet is that we are we started a pilot with doing IPv6 support at the institutes themselves. We have seen that, for example, the sheet of the business plan, and also the numbering plan and the adoption plan, they're all thought about, from a knowledge knowledge perspective kind of view. But we also want to do it in practice, and therefore we really want to go down to the campuses and start helping institutes with the deployment of IPv6 and learn what kind of problems they encounter, so that we can document that again. And I think that came also in the first presentation from Aladdin. That if you start with the deployment of IPv6, you have to start with a quick scan of the hardware, of the software. Is it really, there you are, Aladdin, was talking about your presentation. And you have to make a plan and provide technical hands-on. But the main thing is that you have to build up IPv6 knowledge yourself. The most important part of the adoption and transition part, we have had the pilot now, and we saw that actually with the 5 to 7 days of consultancy, you can really get along with it. You can really start, and you can end up with a good plan of approach, which the institutes can start with actually. And that's what we are, where we are right now. We had the pilot phase. We were adopting. We are asking other institutes to start also, and that's the phase where we are in now. So a few institutes have the plan of approach. They have had the quick scan already and the details of the quick scan, and now it's the next step. Few institutes will carry on with the plan of approach, and new institutes will come on with the quick scan, and we hope to have more and more institutes in that process. Let me see. The other areas we had, except for business plan transition and numeric plan, were the applications. And we noticed that institutes, they worried about their licenses mostly, because the most applications they use are, for example, the library applications, and they are protected by IPv4 addressing. So every student who wants to research something using the library must have an IPv4 address of the institute to be able to access that. In spite of all our federation technology we want to provide them, it's still not arranged. If we don't arrange federational access to to those databases, institutes have to make sure that those databases are accessible via IPv6. So that's one of the worries. We had also within the application part, we had that was last April, the 5th of April. We had a one-day seminar called Continuity Seminar, and it's actually good if you have the IPv6 part related to the subject of continuity, because that's really what institutes drive things as well. And we had invited Cisco, Juniper, and L5 networks, and also a couple of software providers like McAfee, but they didn't show up because IPv6 was too strange still for them to talk about. But in that way, people want to learn more what's happening in the world with the providers, and they learn about what kind of applications have problems or has opportunities with IPv6. In the security part, there were also very good developments, but we noticed that the questions Institute had about the security part are most very technological and very based on one situation in an institute. So we were thinking about how we can do that in a more broader way, but until now, it's case by case actually. And the same is for routing, but of course the hardware vendors within the Surfnet, within the institutes for Surfnet, there's a lot of Cisco hardware, and there's still a lot of different situations over there. So what are we going to do now? This is where we stand at this moment, and the actual plan is that we will continue with the support teams on site, and we're gathering data there and see how we can help. We also will continue with our education ideas, and but not only the technical part, but also on the part where we learn from the adoption within institutes. We will continue with organizing meetings, and also just mentioned on 8 June, the day that IPv6 will be turned on in, I hope, a lot of websites. Then we will organize IPv6 Day in Amsterdam, but that was just mentioned. So if you are in Amsterdam or in the neighborhood, please come by and have fun, I would say. So what are our conclusions and recommendations about this little case study? Well, I would say that IPv6 is not a technology push, because it's of course technology, but you don't have anything different than IPv4, except from when it's customer driven and customers say, hey, there are now sites, people who cannot reach my site anymore. Fear is not a good driver, because it makes risk avoiding it makes people to avoid risks on a fast way, and they perhaps implement technical solutions that you do not want. So try to be try to have a positive talk with your customers. That's what I would recommend. 2011, it seems a good time now to start. So yeah, perhaps for you too. And well, gather your customers together and determine their needs. That's actually what we learned. That was very valuable for us. Suppliers, you should involve them, of course. Again, look at the customer for what's the pace. Are we in line? And yeah, provide value by delivering a tailored support. It's yeah, they like that. And yeah, most important, I think, especially in this area, is that we should share all our knowledge and get together when there's something new and when we learn something. And hopefully, you do that. Contact me if you have something nice to know, and I'll be happy to share what we know to you as well. So, well, I hope that my presentation inspired you to, well, do something to your customers with IPv6. And well, thank you.
Before I ask questions, and I'm sure there will be one, I want to return to an earlier question about dual stack.
Mm-hmm.
And you're saying your customers already have enough addresses. Certainly the Trader Secretariat does. I do at home. I have one at the moment. What is the path within Surfnet? Is it dual stack? Is it ever likely? You were saying before, need two to tango, but are your customers within the Netherlands ever likely to need more V4 addresses? They need V6 to talk to V6 people?
Well, our customers, they have a lot of IPv4 addresses, most of them actually, and so they will actually, yeah, perhaps they even can translate all their addresses to V6 addresses as well. But yeah, for all the purposes, we think and also the learning phase, we think that dual stack is the way to go. So that's what we're trying to support them in as well.
And get more IP addresses from the RIPE NCC.
Exactly.
I don't have a question, I have a comment. Colleagues, for those who will start IPv6, you will face in the beginning a big difficulty in the addressing plan. You will receive /32, distributed /48, /64, and so on. So I would like to praise the great document by Surfnet for the IP addressing plan. I would highly recommend that you guys, whatever you want to start with IPv6, you face difficulty with with the addressing plan, you refer to this document. Thanks you, Maurice, for this great document you have produced, Surfnet. Thank you very much. That's my comment and advice for the users.
Okay, thank you for this comment.
Any more questions?
Brian Boyle, IANA. Maurice, did you find, as you moved towards the campus deployments with your customers, did you find IPv6 bugs, given that IPv6 software is relatively untested in comparison to IPv4 software, network stacks and stuff? And the supplementary question to that is, how helpful were the suppliers of the software with the bugs in, and how quick were they in getting around them, if any?
If I understand the question right, bogus-ing IPv4 software? Mm-hmm. Not already. Yeah, maybe within the Surfnet network, but I'm not aware of that kind of details. Of course, there are. The thing that I heard was about virus scanning, for example, or the thing you have in your desktop for you can say the firewall, the personal firewall things. That is really the software that's giving headaches to our customers at the moment, because some personal firewalls they just discard IPv6 packets, for example. And when we had the seminar about continuity, we asked well, not only the hardware providers, but also a few software providers to come with us and talk about their ideas for the future. But yeah, they reacted like, okay, we have to ask another person within our organization, and then it became very quiet. So, yeah. Does that answer your question? Okay.
Hello, Alan Buxey from Loughborough University. It seems that a few years ago IPv6 was sort of a free world, but recently it seems common that vendors of networking kit and appliances and even software are now actually starting to charge for IPv6, and they're even switching to charging to IPv6 or bumping up to a second license level. Do you think that's a fair business practice, or do you feel that that's a sort of security nightmare and an act of vandalism against IPv6 deployment?
Oh, I'm not aware of. Yeah, you say that routing vendors, for example. That's me. Routing vendors, for example. Yeah, that they are charging extra for IPv6 modules, for example. Than they would do for IPv4 modules. Yeah, I guess that's their business plan. Then I'm not sure how they can get their people more enthusiastic for IPv6 that way. So, doesn't sound good to me, actually. I would do it the opposite. If you still want IPv4 hardware, then put a lot of money on it. And if you do IPv6, well, maybe a little support from who knows who. Yeah.
Maybe if the modules were bug-free, you wouldn't mind paying for them.
But are there vendors in the room?
Can I just Tim Robinson at Northwest? Can I just make a comment on that, Alan? It's gone. In
the corner there.
Mic, but
microphone not working.
Ah, yeah. Oh, sorry, I didn't see it over there.
Do you want, is it working? Do you want this one? Do you want this one?
Try that again. Tim Robinson, Net Northwest in the UK. I think Alan's got it wrong. It's gone the other way. Cisco certainly have started bundling IPv6 for free or at lower levels of their bundles. So where you used to have to move up their payment stack to get IPv6, it's now much lower down the stack. So I'm not sure at the router level that's actually happening. And can I make one other comment, though? What do people think about the presence of all these 6-to-4? Isn't that confusing the network? Sitting here, for instance, if you do a trace route to Google's IPv6 site, sat here, the first hop is actually in the Netherlands, and the next hop's in Google. And we all know that isn't true. So people are going to be confused and think they're actually running V6, when they're not running it at all. They're actually running a 6/4 relay until it gets somewhere much closer to the cores of the networks.
Yeah, I agree. Yeah, it's a good comment. Thank you.
Dave Wilson, IANA. First, I want to say this is actually one of the clearest, most concrete talks on IPv6 I've seen in years. It's got a bunch of ideas that I plan to steal. Thank you very much indeed.
Thank you.
As regards to the great work that you did in getting clients to work together and make requirements document and business case, how do you follow through on that? How do you get them to implement?
Yeah, that's a phase where we are starting right now with the on-site support we are doing. We just had a pilot, and we just started with a quick scan of the hardware and the software. And now we are in the phase that the next step is starting with the plan of approach that has been created within those institutes. And from there we can learn again how all those templates we created in the first phase are being used and can be enhanced in the couple of months. So that's something that has to be developed first. Yeah, in the first thing, that's what we are doing as quick as we can, I would hope. Thank you.
More questions?
In front.
What's the best thing to do with vendors that say like, yeah, IPv6 will be in the next release? Because I have a lot of experience with different vendors that, yeah, we buy a box, they say next release IPv6 will work. And then it will be like, yeah, IPv6 works, but you can't run in dual stack. You also can't do any ACLs on it, but you can give it an IPv6 address.
Yeah. Well,
I'm seeing that a lot of stupid bugs, and
that's what we experience as well. That just the people are waiting for the next iOS to come out or whatever, and they are really having a problem with that. But our idea is that if we gather a lot of people, then the power of customer, as you would say, would become bigger, and that's the way that you have to get attention from your supplier.
Is it an idea to combine, for example, in the Netherlands with Surfnet and RIPE, to make a big statement to the vendors like, hey, where's the IPv6 support?
Yeah, that would be wonderful. I think that if we have clear data, for example, which application does not work.
I can give you a lot of data.
No, that's perfect. And if there are more institutes who said, yeah, we recognize it and we also want it, then we can make a petition actually.
Why not?
There, yeah. Sorry? IPv6 community. Yeah, that's actually a very good plan.
More questions?
No?
Mike Norris, also from IANA. I was just wondering, is there any attention being paid to the service provider side? You've got a federation in Surfnet, and you've got your institutions on the one side providing directory service for their students. But what happens if they are all V6 and they can't access some of the e-learning or research services which they're federated to access and they're paying to access? Is there any discussion going on with the SP community, service provider community?
Not that I'm aware of, and actually those worlds seem to be very much separated as well, the network world and also the SP community. I think that personally, I think the best way to go is to still have the people who provide the service to go to them and ask them to continue with these problems, because they will face it as well, and they are actually the one giving the service. So for example, the Kluwer or the Walters or that's Dutch. The publishers actually, we should talk to them to provide their services. Whether and I would not say in IPv6 to maintain the situation to protect the content using IP numbers, but going to a service provider model, that would be the best.
This was actually brought up at the Refeds Day on Sunday, and there is a proposal to do more work on these sort of federated proxies, mostly because content providers aren't offering federated access. The federated proxy would also allow you to do a transition of the federated proxy could support v6 for those publishers that don't get around to offering v6 themselves. So in effect, you've got a dual stack federated proxy, and you're trying to overcome some of those problems. There is a fear that the federated proxy will then live forever, because the content provider will then be able to continue to do v4 and continue to not do SAML. There was another question.
I just wondered about the BIF, the federation thingy. Yeah, wave. No.
The discovery service.
The AI service, like the Surfnet Federation, or okay.
Okay, so this has popped up, I think, on the Refeds mailing list as well, and Surf Federati is dual stack for its core applications and many of its service providers and identity providers. WAIF, the Danish federation, is not dual stack; it's IPv4 only, and that is going to be explored. There's a project to actually look at Is it true that only 0.03% of the internet, or 2% of the internet, is V6, and is it not worth investigating? And those communities are actually going to look. Surfnet and WAIF are going to pair up and, compare and contrast, because Surf does do V6 and WAIF doesn't. What is the model?
I'm happy that you are so knowledgeable about what Surfnet does, because I didn't know. Thanks.
Because Terena is a Surfnet customer.
Going back from federations to more equipment, Raymond Ostemanaskas from LitNet. Have you tried to specify any features of IPv6 that are absolutely necessary for the beginning of the transition? Any particular features of the equipment?
No. Do you recommend any features? So do you think of any features you would?
Because, well, at least in our case, universities are buying equipment from time to time.
Mm-hmm.
So maybe now it's a good thing to consider IPv6 as a requirement for their equipment.
Yeah, okay. Yeah, well, of course we have IPv6 BGP, what we recommend as first step for equipment, but we don't have a list or something like that for people to address when they want to buy new equipment and actually, or new software, and actually have to look for.
Sorry, Rob Evans from
Good point
UK.
as well.
On that particular point, there's a RIPE document, RIPE 501, which is a template for requirements to put in procurements for V6, for IPv6. It's being revised at the moment, but it's a good template to start from as it is now.
Okay, thank you.
Yeah, and I think some other RIRs have adopted or promoting the use of RIPE 501 as well. I don't know, Miriam, are the RIPE 62, are the streams available? Can you play back the RIPE? Yeah, you can? Oh, very good. It's well worth watching. The most recent RIPE meeting in Amsterdam had a significant amount of IPv6 content, and it's worth watching just so you can hear Chris ask the world's longest question that was submitted via IRC. I don't know if we have any more questions. You can find the speakers throughout the conference, and it's pretty much the end of the day. So I thank you for your time, and please thank the speakers.
And thank the audience as well. Oh.
Ik heb alleen maar een Linux. Ik heb normaal een Nokia. Allemaal die zijn, maar ik maar geen iPhone. Dat vind ik overbest. iPhone.